Hello, welcome to another TypeScript basics video. In this part, we are going to look at how TypeScript's module resolution works. Module resolution is process of identifying where to load module files from at compile time. Let's say we have module A and module B. Module A imports something from module B. During compile time, TypeScript tries to find module B to understand the shape of the exports imported from module B so that it can do type checking. Note, this is not runtime module resolution. Runtime module resolution happens when the transfile code is running. Runtime module resolution is done by module loader, either provided by the platform that provides JavaScript runtime like Node.js or browser, or by the third-party libraries. For example, Node.js supports CommonJS module and it uses its own strategy to find and load modules at runtime. Modern browsers support ECMAScript 2015 modules natively. Most module formats are supported by most browsers with the help of third-party libraries. For example, Require.js supports AMD modules. System.js is another popular module loader that uses its own module format but supports other module formats by wrapping them in its own module. Okay, coming back to TypeScript. TypeScript module resolution only takes place at compile time and it takes no part in runtime module resolution. Okay, now we understood what module resolution is. Let's take a look at types of module resolution and how they work. TypeScript supports two types of module resolution. It is also known as module resolution strategies at the time of recording this video. They are classic and node. During module resolution, compiler looks for module file in one or more folders defined by the strategy used. In those folders, it looks for files with some predefined extensions. The first file it finds will be used as a module file. In TypeScript, you can use relative or non-relative path when importing modules. Paths that begin with slash, dot slash, or dot dot slash are relative paths and they are relative to current folder. Paths that don't begin with any of those are non-relative. Let's look at some examples for relative path. This one looks for module B in the current folder. Dot slash refers to the current folder. This one looks for module B in a folder called child inside the current folder. This one looks for module B in a folder called parent inside a folder one level above the current folder. Dot dot slash means one level up from the current folder. This one looks for module B in root folder. Slash indicates root folder. Let's look at some examples for non-relative paths now. This one indicates to look for module B. The search location for module B depends on the type of module resolution strategy selected. This one indicates to look for module B in a folder called parent. Again, the search location for folder called parent with module B in it depends on the type of module resolution selected. The combination of module resolution strategy and the path formats leave TypeScript with 4 different ways to resolve module imports. Let's look at them in detail one by one. First, let's look at how TypeScript resolves relative path when classic strategy is used. Let's say we are importing something from module B from the current folder. Now, TypeScript compiler looks for a TypeScript file called module B in the current folder. A file is TypeScript file when its extension is one of TS, TSX or D.TS. TSX is used in React projects and D.TS is TypeScript type definition file. Whenever TypeScript searches for TypeScript file, it looks for TS file, then TSX and then the type definition file. This means if a folder has both TS and TSX file, for example, then TS file will be used as it comes first in the search order. If no TypeScript files found, it looks for JavaScript file called module B. When searching for JavaScript file, it looks for JS file first and then JSX. JSX is JavaScript version of TSX used by React projects. Here is another example where module B is loaded from folder called child present in the current folder. So the compiler starts searching for module B TypeScript file first and then JavaScript file, but this time inside the child folder. Now let's look at how classic module resolution works with non-relative path. We take the same example where we import something from module B. TypeScript compiler looks for a TypeScript file called module B in the current folder. If not found, it moves up in the hierarchy one step at a time, looking for module B TypeScript file until it reaches the root of the folder hierarchy. If no file is found, it moves to the current folder and looks for type definition file called module B inside the @types folder in the node modules folder. If not found, it continues its search by moving up in the folder hierarchy. If no luck finding the type definition file in the parent chain, then it moves to the current folder and looks for module B JavaScript file. Again, it moves up in the folder hierarchy looking for module B JavaScript file. Finally, it gives up and declares that the module is not found. Let's look at how node module resolution works with relative paths. If we import something from module B from the current folder, then the compiler searches for TypeScript file called module B in the current folder. If not found, it looks for a folder called module B in the current folder. If the folder is found, then it looks for package.json file with typings key in it. If typings key is found, then it looks for the file specified as value for this key. If typings key not found or the file specified as value for typings key could not be resolved, then it looks for types key. If types key is present, then it looks for the file specified as value for this key. TypeScript follows node module resolution process recursively to resolve the file specified as value for types or typings key. If package.json is not found, or it doesn't have typings or types key, or the file name specified in those keys could not be resolved, then it looks for TypeScript file called index inside module B folder. If module B folder doesn't exist or the compiler doesn't find the file it is looking for in that folder, then it starts searching for JavaScript file called module B in the current folder. If those files are not found and module B folder exists with package.json, then it looks for the file specified as value for main key. Again, it follows node module resolution process recursively to resolve the file. If still not found, it finally looks for JavaScript file called index inside module B folder before giving up. Okay, now let's look at how node module resolution works with non-relative path. Let's take the same example where we import something from module B. The compiler looks for node modules folder in the current folder and looks for a TypeScript file called module B in it. If the TypeScript file is not found, then inside the node modules folder, it looks for module B folder with package.json file. If package.json file is found with typings or types key in it, then it tries to resolve the file specified as value for that key. Again, TypeScript uses node module resolution recursively to find the file. If still not found, it looks for TypeScript file called index in the module B folder inside the node modules folder. Then it looks for module B type definition file in @types folder inside the node modules folder. If it could not find any of those files, then it moves up in the folder hierarchy one level at a time and applies the same search mechanism. It continues the search until it reaches the root folder. If none of those files are found, it moves to the current folder and looks for JavaScript file called module B inside the node modules folder. If not found, then inside the node modules folder, it looks for module B folder with package.json. If package.json file is found, then it looks for a file specified as value for main key. Again, file is resolved recursively using node module resolution process. Then it looks for JavaScript file called index inside module B folder. If it could not find any of those files, then it moves up in the folder hierarchy one level at a time and repeats the same search mechanism until it reaches the root folder. Then it declares that the module is not found. Let's look at an example now. I have VS Code open here. We have module A, which imports something from module B from the current folder. And here in the tsconfig.json, I have specified module resolution as classic. I have also set trace module resolution as true so that we can see how TypeScript searches for modules. If you notice, module B doesn't exist in the current folder. So if I run this, it will fail, but we can see what TypeScript has done to find the module before giving up here. If I change module resolution to node and run again, you can see TypeScript looks for module file differently, as you can see here. Okay, that's it for now. Hope this video is useful. I'll see you in the next video. Thank you.